Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're doing 1.3 today, so make sure you're taking notes and following along in your note packets that we passed out at the beginning of the year with your materials pickup. So today we're doing solving linear equations is the name of this lesson. Our essential questions are be able to define the properties of equality and be able to solve linear equations using the properties of equality. All right. So, two expressions, numbers and variables. An equation is two expressions, numbers and variables separated by a what? By a... Oops, gotta turn on the actual marker, I guess, huh? By an equal sign. And a linear equation is ax equals b, where a and b are constants or just numbers, and a does not equal 0. Properties of equality, you probably know these and have been using these for a while, but these were proven, and it's basically how solving equations works, right? So if you add something to one side, you have to add it to the other side, and all those other kind of things that we do in algebra. So basically, if a equals b, then for the addition property of equality, a plus c is going to equal, what do we think? If we got to maintain equality on both sides, we also have to put b plus c. Yep. Nice. So fraction property of equality, if a equals b, then what are we going to put for the second line here? We're going to put a minus c equals b minus c. Now the multiplication property of equality and division property of equality have one more extra step we have to be careful about, and that is if a equals b and c does not equal 0, then AC equals BC. Okay, this is more important for division. The reason why we can't have C equal to 0, let's just look at this here. If A equals B and C does not equal 0, then A divided by, oops, that was really bad. A divided by C has to equal B divided by C. But the reason why we can't have C equal to 0 is what can't we do in math? It's like the number one rule. If we have 3 over 0, what happens? What do we get in our calculator? We get an error because math doesn't even allow you to do that. It's not allowed to divide by 0. Okay? All right, new color here, new section. Fraction busting. This is super useful. Okay? So let's just get rid of all the fractions in one step. I'm going to encourage my Algebra 1 students to do this as well, okay? So basically what we're going to do is we're going to multiply the whole equation by something to get all the fractions to cancel, all right? And the way we're going to do that is we're going to find the least common multiple, or LCM. Oops, that's not C. Of the denominators and multiply every term by that number. So what are multiples? I'll give you a second to write that down real quick. Let's see if I can box this for us. That was really bad. This does not want to work. That's a little better. Okay, what are multiples of numbers? Well, if you recall, so if we do multiples, the two denominators we have here are 3 and 5. So multiples of 3 is when you count up by 3. So we have 3, 6, 9, what else we got? 12, 15, 18, 21. Remember that? I don't know if you remember that Schoolhouse Rock thing. It was 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. That's probably just me. That's probably a really old thing you guys haven't seen before. But yeah, I like the multiples of 3. Then we also need the multiples of 5. counting up by 5s, we got 5, 10, 15, 20, 25. So we want the smallest number that divides by both 3 and 5. So that's going to be, looks like we got, the smallest number is going to be 15, right? Okay. Another thing you can do is just count up by the biggest number here, which is 5. And when you count up by 5, see if each number divides by 5 and 3. So 5 doesn't divide by 3, 10 doesn't divide by 3, 15 does divide by 5 and 3, so that's going to be our least common multiple. All right? So we're going to multiply, and you'll see why this is so nice, but we're going to multiply in each term by the least common multiple, which is 15. And that is going to bust our fractions and get them out of here. All right? So we're going to multiply this, multiplying 15 times 1/3, 15 over 1 times 1/3. I'm going to do this first step, and then we're going to get away from this later, but 15 over 3x plus, what's 2 times 15? 30 over 5. And then 6 times 15 is 90. If you're comfortable just doing 1/3 of 15 and, canceling, 15 go to 5 go to 1, this goes to 3, and you get 6. That's totally fine, but we're just showing you what's happening here. You're multiplying it across. Multiplying fractions, no big problem. Top times top or bottom times bottom. And you can also do canceling vertically and diagonally. So what's 15 divided by 3? That's going to be 5x. And what is 30 divided by 5? That's going to be 6. And we have 5x plus 6 equals 90. Next step to solve for x. Okay, so we need to get x by itself. We have 5 times x and we have plus 6 here. What are we going to do first? The addition or multiplication? Hopefully you said addition first. We're going to get rid of the addition by subtracting 6. We do the opposite of PEMDAS with these kind of problems, okay? So we get 5x equals, that's going to be 84. And what's the last step to solve for x? We're going to divide by 5. Now, this is very, very important. I want you to hear me now, okay? For Algebra 2, it's going to be very important that we use exact answers. You guys, this is kind of like an honors class for the most part. And so exact answers means no rounded decimals, and if you're using square roots, you do the appropriate cancellation of square roots or reducing square roots, and use improper fractions. So 84 does not divide by 5. So we're not going to do mixed numbers or anything. This is actually going to be our final answer. Okay? So just keep that in mind that we're not going to do approximations and stuff. It's going to be very important that you guys know how to, just reduce and cancel things and get final answers like this. Okay? All right. You're going to do these next 2 examples on our own. But first, I want to just go over the steps for, turn my paper over here, solving equations steps. Okay? So there's some steps we want to follow to just keep, solving nice and easy for us here, okay? First thing we want to do is fraction bust, which we just learned just now. We're going to fraction bust. Second thing we're going to do to both sides is we're going to simplify both sides by doing 2 things. What are those 2 things? We're going to distribute. We're going to combine like terms. And then the last thing we're going to do is solve using inverse operations. Okay, and that means PEMDAS in reverse SADMAP. So basically we're going to do addition, subtraction first, then we're going to do multiplication, division, then exponents, and then grouping symbols. All right? So yeah. So those are the steps. I'll give you a second to write those down. All right, so we have 4 examples here. See if you can give these a try. Otherwise, you can just wait and we'll go through these examples together, okay? But I'd like you to do as much as you can on your own, see how you're doing. All right, so we have this one right here. First of all, is there any fractions to bust? There is fractions to bust. We only have the 9 in the denominator, so that's automatically going to be our fraction we're going to bust, or the number we're going to multiply by. We're going to multiply by 9. So 2 times 2, or 9 times 2 ninths is going to be, the 9s are going to cancel, we're just going to get 2x. 8 times 9 is 72. And 16 times 9 is 144. All right, anything to distribute? I don't see any parentheses here to distribute. Any like terms to combine? So like terms have to be on the same side of the equal sign. So if we had a 5x right here, it would be these two would be like terms, but we don't. There's no like terms. Now we got to just solve for x. We have this 2 times x, and we have the 72. We want to move stuff away from x. So what are we going to do first to move stuff away from x? We're going to subtract 72 from both sides. So now we have 2x. 144 minus 72 is 72. And the last step to solve for x is to divide by 2. X is going to equal 36. All right, number 2. Any fractions to bust here? No. Any thing to distribute? We do. We got a couple things to distribute. So we're going to do 5 times x and 5 times negative 2. Negative 4 times 2x and negative 4 times 7. 5 times x is 5x. 5 times negative 2 is negative 10. Negative 4 times 2x is negative 8x. Negative 4 times 7 is negative 28 plus x. Feel free to say out loud what I'm saying to help you keep motivated and connected with all this, all right? Anything else to distribute here? Any like terms to combine? Same side of the equal sign. I do see some. I see some right here. We got the negative 8x and we got the positive 8x. So how do we combine like terms? What do we do with the coefficients, the numbers in front? We're going to add them up. What number's in front of the x here when there's nothing there, though? There's going to be a 1 there. So we're going to add the like terms, which is negative 8 plus 1, which is going to be negative 7x minus 28. Now we got to move all the x's to one side. So do you guys want to move the 5x or the negative 7x? I might move the negative 7x to make it positive. You could also move the negative 10 and the 28. I like to move my x's first, though. It's just kind of a habit. There's 4 things you could do here. You can move this, 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 or that. It does not matter which, but I like to just move the x's out of habit. So we got 5x plus 7x is 12x. Minus 10 equals, what, negative 28? Now to solve for x, we're gonna divide by 12 or subtract 10. We're gonna add 10, or add 10, sorry, I meant to say add 10. 12x equals what, negative 18? Last step is to divide by 12. Now we need to find the greatest common factor that goes into 18 and 12. What's the biggest number that goes into 18 and 12? It's going to be 6. And how many times does 6 go into negative 18? Negative 3. And how many times does 6 go into 12? 2. Okay, so keeping that in mind, you always want to reduce at the end. You have fractions you want to reduce, square roots you want to reduce. We want no, excessively large or unnecessarily large numbers, okay? All right, 2 more to go. Here we go. Switch to a new color, green. All right, we have 3, 4, and 6. We need the fraction bust here first, right? I kind of gave that away, but so we're starting with 6. 6 is the biggest number. 6 doesn't divide by 4, so then we got to count up by 6 is 6 and then 12. Does 12 divide by 3 and 4? It does. So we're going to multiply each term by 12. The x by 12. Negative 1, 6 by 12. So 1/3 of 12 in the front here is going to be 4x. 1/4 of 12 is going to be 3. Equals 12 times x is just 12x. And then negative 1/6 times 12 is going to be, what we got there? Negative 2. All right, let's move the 4x this time. How do we move the 4x to the right-hand side? Going to subtract 4x. So we get 3 equals 12x minus 4x is going to be 8x minus 2. Now we're going to divide by 8 or add 2. We're going to add 2. We take care of addition and subtraction first. So we get 5 equals 8x. Last step, divide by 8. I'm going to flip things around here. X equals 5 over 8. Does 5 divide by 8 nicely, or can we reduce that? We cannot, so there's our final answer. Pause the video here if you need to write down the rest of the work. All right, last example, number 4. First of all, any fractions to bust here? Yeah, we got 3, 5, and 10 in the denominator, so we're going to start with 10. Does 10 divide by 3 and 5? It does divide by 5, but not 3. Count up by 10s, then 20. Does 20 divide by 3 and 5? Nope, 20 doesn't divide by 3. Then 30. Yeah, it looks like 30 divides by 3, 5, and 10. So we're going to multiply each term by 30. All right, now 30 times 2/3 is going to be 20x. Plus 1/5 of 30 is 6. 2x times 30 is 60x. And then we got negative 3/10 times 30 is going to be, what, negative 90 divided by 10, which is negative 9. All right. I'm going to move the 60x to the left-hand side this time. How do I do that? I'm going to subtract 60x from both sides. And I'm also going to do it in the same step here. I'm going to subtract 6 from both sides too. Okay? I'm going to move stuff away. I'm going to do 2 things at once here. I'm going to move the x's to one side and the numbers to the other side, like all in one step. So we get negative 40x equals what? Negative 15. Last step to solve for x is to divide by negative 40. X is going to be, what number goes into 15 and 40 nicely? I think that's what? That's 5. So 5 goes into 15 3 times. 5 goes into 40 8 times. 2 negatives make a positive. So we get 3/8. Can we reduce 3/8 anymore or no? That's our final answer. All right. Nice job, guys. Hope you enjoyed that as much as I did, which was a lot. Just can't get enough of this stuff. Thanks for watching, and go ahead and finish the homework or work on the homework, and we'll take questions on this section the next day. Have a great day.